Okay, so it's time for us to write our simple markup strategy. It's one of the strategies that's going to implement the iSudoku strategy, and that's the one that we're going to be putting in the list, and that's the one that's going to help us to solve the puzzle. Now, I want to show you an example of a simple markup strategy. Basically, let's take this cell right here, right? Essentially, what we're going to do is we're going to find the possibilities for the column and for the row that this cell intersects in. So this cell is for this column and for this row. So initially there are 9 possibilities. It can be 1, 2, 3, 4, 5, 6, 7, 8, 9. But you see that on this row we have 9, 2, 3, 7, 6, 8. So it can't be 9. It can't be 8. It can't be 7. Right? It can't be 9, 8, 7, 6. It can't be 2 and 3. There is no 4. Now let's look at the column. The column has 5, so this 5 also goes away. So we're stuck with 1 and 4. Now the 1 and 4 are the possibilities that we can, play around with. We can just be basically what the simple markup strategy would do is it would say this one is solved for. This one, we already, did whatever we could, and we move on to this guy. What could happen is that whenever you run through the whole thing once and you do it again, what happens is that you actually solve for this guy, let's say, and for whatever reason, this becomes 1. I mean, I don't know if it solves for 1 or not, but let's just say that it does. I mean, it can't because in the group there's a 1 already, but let's just say this 1 wasn't here. If this was a 1 and you were able to solve it, then the next time around, this 1 would eliminate this 1, and then you would have only 4 left, right? So that's kind of like the gist of it all. Let me just take this 1 out. And that's what we're going to do with our strategy, right? It's just basically going to go through it once, and then we're going to compare the states, be like, oh, okay, cool, the state has been changed. Let's just run it again. It's going to run again, and it's going to help it to reduce until the whole thing is solved. So hopefully that makes sense. And let's go and create our simple markup strategy. I'm going to go into strategies, create a new class, and then I'm going to name it Simple Markup Strategy. So Simple Markup Strategy. Great. It's going to implement the iSudoku strategy. And see now, it says implement the interface. So the interface says that it has to have this method. It's not implemented. However we implement it is up to us. One thing I'm going to do is, I'm going to say that there's a private read-only field. So there's a field of Sudoku. So Sudoku mapper, and that's going to be the one that we created, if you remember, the one that figures out which block we're in. And we need to use the workers, and we're going to use dependency injection in order to get that dependency in. So we are going to say Sudoku mapper, and then we're going to say the one in here is going to equal to the Sudoku mapper. So this is just simple DI. And then we're actually going to go ahead and create our solve method. So at the end, we're going to return the Sudoku board. And that should do it. Now what we're going to do is we're going to iterate through the entire Sudoku board. Remember how to do that? We've already done it. So go to displayer, get this guy, take it out, and we don't need these guys. Take them out. Remove the spaces. And there you go. So here, what we're going to say is, we want to say if the state is already, or if the cell is already not solved for, then go ahead and solve for it. We also have that code as well, and that was in our state manager, which tries to figure out whether the cell is solved for or not, so they can say whether it's true or false. And we're going to go ahead and kind of like use that, and we're going to say, okay, well, if the row for that column it's 0, or there is multiple possibilities, then what we're going to do is we're going to go ahead and solve it. The way we do it is like this. We're going to go find all the possibilities in row and column. Then we're going to find all the possibilities in group. And then, because right now in the example, remember, this cell, I forgot to mention one thing. This row and the column right here, this column right here, right? Goes all the way down. Those are the ones that count, but also this number, this cell that we're trying to solve for, couldn't have numbers in that were in this section, right? In this block. So let's say if one of them was 1, that would eliminate the 1, and this would have stayed with 4. So we need to find the possibilities in row and column, find the possibilities in a group, and then find the intersection between the possibilities in row and column and then the group. And that's exactly what we're going to do. So I'm going to say possibilities in row and column. Equals get possibilities. It's a hard word to spell. In row and col. And that method doesn't exist. I'm just kind of like creating them, and then I will fill it up afterwards. I'll fill it in afterwards, where you need to pass in the Sudoku board and row in the column. Then we need to find the possibilities for the, for the group, or the section, but in this case, I'm going to call it group. And, or we can even say section or block, just to be closer to the lingo that people in Sudoku community use. And get possibilities in block. So get possibilities in block. Once again, that's going to take Sudoku board, a row, and a column. And then I'm going to say Sudoku board, row column equals to get possibility intersection. So get possibility intersection. Great, and I'm going to pass in the possibilities in row and column and the possibilities in block. And that should do it. Okay, so let's create these guys now. I'm going to do that. So just hover over it. And for each one, just generate a method. It'll automatically do it for you. And then the third one, there you go. So now let's start with get possibilities in row and column. I can actually go ahead and put this first because I pushed it down. Put it in the order in which they're going to be called for. And the intersection is going to be at the bottom. Great. So get possibilities in row and column. What we're going to do is we're going to create an array, just like in the example I've done. And I'm going to say possibilities equals 1 to 9, because there are 9 possibilities in each given cell. 1, 2, 3, 4, 5, 6, 7, 8, 9. Great. Then what we're going to do is we're going to say, okay, for int col equals 0. Col is less than 9. And then col plus plus. Increment that. So we're going to say if, and once again, this method that I'm about to write does not exist, is valid single, then the Sudoku board given row and column. So I'm going to actually change these names to given row and given column. Can do the same thing here. Given row, given column, just to be more specific. And I'm going to say for the given row and for the column that we're iterating on, if it's a valid single, then what we're going to do is we're going to take the possibility. Let me just create this. And this is going to be all the way at the bottom, just a helper method. We're going to say the possibilities Sudoku board given row and column minus 1 equals 0. You'll see exactly what this is just in a minute. Let me just finish writing the code, and then I will explain to you. So then we can actually borrow this and say the same thing for row. And if row is less than 9, add 1 up. It's just the only difference is for all the rows we're iterating and the given column. So same thing here, given column. If it's a valid single, then for that, for all the rows that we're iterating and for the given column, say minus 1 and then equate it to 0. Don't worry, I will go over all of this. Just bear with me. I'm going to say convert to int 32. And then I'm going to say, so I'm converting basically. Then I'm going to say string join string empty, and then possibilities select. Remember the select from link p. So it's just the possibilities. Selecting all the possibilities where p is not 0. And that's it. Now let's actually go over this. This is actually not that bad. But before that, actually, let me just, fill out the is valid single so that it all makes sense all together. I'm going to say cell digit, and then I'm going to say return cell digit not 0. So if cell digit is not 0 and cell digit toString dot length is less than 2, then that's it. So let's go over this real quick. What I'm doing is I'm saying I have 9 possibilities for any given row and column, whether it's this, any one of them. I have 9 possibilities. So remember how I wrote from 1 to 9? So that's what we're doing here. And we're saying, okay, for all the columns, go and iterate through all the columns. So for Sudoku board, given row might be 0. So let's say it's 0 here. And the given column is going to be 0. It's going to be 1. It's going to be 2. It's going to be 3. So you're going through all the columns for any given row. So if the row is this, then you'll go down all the way here. If the row is this, you'll go down all the way here. In our example, the row was here, so you would go all the way down here. And then the row is here, so you would go through all the columns for that row, right? And essentially what you're doing, see the possibilities? It says the possibilities. So Sudoku board, given row column, whatever it is an is valid single. So if that given cell that you are on, that you are iterating, right? When you're iterating, and let's say it's this guy, like this one, right? You are here, and then you go here. This is a valid single. Why? Because you're going to pass that into is valid single, and is valid single is going to say, is it 0? No, it's not a 0. Is the value, the length, less than 2? Yes. Okay, well in that case it's a valid single because it's not a 0, and the length is less than 2. So it's a 1. And you can basically then say, all right, that makes sense. If it's not a 0 and the length is actually, we can just be explicit and say 1. So this will have length of 1 and it's not 0. In this case, it's a valid single. So if it is a valid single, then go to possibilities and say Sudoku board given row column. So the given row column would be this guy, whichever one we just selected. So the value of that will be 2. So what we want to do is we want to cancel out the possibility in the possibilities. So how do we do that? We know that we want to get rid of 2. And we know that the indexes in arrays work from 0. So that we can just say go to 2, because that would go to 0, 1, 2. It will go to 3. So what we do is we say -1. We grab that value, which is this valid single, and we say -1 from that value, which will turn that into 1. And when we grab the index from the possibilities, it'll go to 0, 1, which is 2. and we're going to say turn that 2 to 0. So then what you're going to have is this. So 2 is no longer a possibility. Get it? So that is the trick there. And then here, we're doing the same thing for the row. So you go for 9, and if 9 is there, then you basically go 9 minus 1, it's 8. So 0, 1, 2, 3, 4, 5, 6, 7, 8. You'll cancel out 9, it's going to become 0. So then you're going to, go on and on and on until you're left with either one possibility or many possibilities. Then what you're doing here is you're saying convert. String join is essentially what it does is it takes an array of elements and puts them together based on a delimiter. In this case, there is no delimiter. So if you give it a list of, let's say, if you give it a list of 1, 2, 3, like if you give it 1, 2, if this is your array, string join based on a string empty is going to return a string that looks like this, 1, 2, 3. That's it. That's all it's doing. It's just putting it all together. That's all. So it's going to put it all together. But what is it going to put all together? It's going to select all the possibilities where the P is not 0. And we've already went over link. So essentially what it's doing is it's saying, okay, grab all of the values that are not 0. So let's say 2 was zeroed out and 9 was zeroed out. What we would do is we would only grab 1, 3, 4, 5, 6, 7, 8, and that would turn into a string. So it would look like 1, 3, 4. It literally looked like this. 1, 3, 4, 5, 6, 7, 8. That's it. And then we would turn this string into a number. So that's why we're saying convert to int32. Got it? So that's actually not that complicated. It looks complicated, but it's really not. And let me just put the numbers in correctly. 1, 2, 3, 4, 5, 6, 7, 8, 9. Great. We have all the stuff lined up here, and we're looking good in the get possibilities and row and column.